recorded on this computer. Okay, so as a quick reminder about how this works, you should have already watched the videos. Today we're going to focus just on sigma notation, and we're going to leave the beginning of compounding interest until Thursday. Okay, so Thursday we'll do compounding interest, and today we're just going to focus on sigma notation because I know that a lot of you really are not comfortable with sigma notation. We're going to use it a lot, so definitely let's spend some time going over sigma notation. So as a reminder, well, yeah, absolutely. Let's do some sigma notation. So as a reminder, here's how it's going to work. I'm going to throw up a question, and I'm going to let you all vote on it. So I'm going to activate the poll, and you're going to be able to choose, whether the answer is A, B, C, or D. I'm going to give you a couple of minutes to work on it. And at the end, we'll see based off of how well the class does, like how much of an in-depth explanation I need to do to go into it. And if people are definitely struggling, then I can talk a little bit more about it. Okay, so let me, without further ado, yes, I know that the lecture is being recorded. Is this the question I want to start on? Actually, it's not. We're going to start on this question. Okay, so I'm going to launch the polls here, and I'm going to give everyone a couple of, stupid thing. And I'm going to give everyone a couple of minutes to work on this. And then once you think you know the answer, plug it into the poll. I'll be able to see roughly how everyone has voted. And then afterwards, we'll go into it and I'll take it up. And hopefully it'll clarify it a little bit. Are we allowed to ask homework questions later? Absolutely. So after this hour of lecture is my office hours, actually. So basically, for those of you, if you haven't seen where my office hours occur, basically it's I'm going to be here 5 to 7 Tuesdays and Thursdays. One of those is normal. Our Thursday lecture is 5 to 7. The first hour, we're going to do these poll questions. We're going to, you're going to work on these questions. I'm going to take them up after. And then the second hour of that period from 6 to 7 o'clock is going to be office hours. So in those office hours, you guys can ask me anything that you want. Of course, if you ask about homework questions, there's only so much I can say, right? Like I can't go into depth, like I'm not going to solve them for you, but we can still talk about them. Absolutely. And I'm happy to provide help in that sense. For those of you who are asking about, like, can I post on Piazza? You absolutely can. Just I've had to warn a couple of students now because they got into Piazza, which is really cool. And in the process of being in Piazza, though, accidentally we're posting solutions to the assignment. So all I'd ask is if you're going to ask assignment questions on Piazza, just make sure that you're making your posts private, right? Like you don't want to accidentally post a solution because that would actually be an academic offense, right? Yeah, and I think if any of you are using the browser version of Zoom might not have the poll show up. I'm not 100%, but I believe we were running into that issue last year. That being said, I think you're all probably, spending most of your time on Zoom, in which case it's probably worth having the actual client, right? The desktop client. Yeah, I mean, for those questions, 18 to 22, I mean, a lot of people are talking about them already on Piazza. So in fact, the answers are more or less up there. You just have to go find them. And if you're not 100% certain as well, you can ask and we're happy to go through them with you. Something important to keep in mind is you often don't learn from the answer, right? So even if any of you want to check whether an answer is correct, you've worked through a problem, you got like 17 or something, you want to know, hey, is 17 right? Our answer on Piazza is going to be, show us your work, show us what you've managed to do, and then we'll critique your solution to make sure that you didn't just get the right answer, but you did the right thing in getting that answer, right? The answer key to the homework, like the assigned homework, that will be posted. It'll be posted right beside the assignment. But that's not going to be until after the assignment is due, obviously, right? Like we won't post the answers before the assignment is due. Oh, to my notes, that is in the same place that you find my notes. If you keep reading that paragraph, eventually it says, here are the solutions to some of the problems, not all of them, but some of them. There are no tutorials you can join. Well, then you can't go to tutorials, but you can still come to class and participate in our things here. You can go to office hours, you can ask questions on Piazza. So there's lots of things that you can do if you can't go to tutorials, and that's okay. Yeah, so Sylvia, same sort of thing, right? The answers to the problems at the end of the book are in the, if you look at the paragraph that says where the notes are, it'll say there's also solutions in there as well. Okay, everyone. So we are at 4 minutes here, but I do not have nearly as many votes as I would like. So post a picture of the textbook problem on Piazza instead of using LaTeX. Yep, lots of people do. Can you see the recording of the course? Yeah, you'll be able to. I'll show you all that in a second. For now, though, everyone, I want you to get these votes in. And importantly, let's say you don't know what the answer is, and I suspect some of you don't. I want you to guess at random, okay? Because that noise, when you introduce noise into the system, it tells me that students don't understand what's going on, right? So if you don't understand what's going on, and you only let the people who know what's going on answer, then I'm going to think that the class understands what's going on, right? And I'm not going to go into any depth in the question. So it's very important that even if you don't understand what's going on, obviously give it your best bet, but make sure that you get an answer in there in the poll. Okay, interesting. Yeah, if it's the numeracy stuff is, I mean, mathematically, it's mostly multiplication, right? There's a little portion that uses logs. So I don't know if that's new, but for the most part, it's multiplication and just can you read and follow the instructions? That's kind of what we're doing. Can I take your class, but I choose other teachers? Absolutely. Yeah. All right, we're at a pretty good number here, about 80%. So I'm going to close the poll in about 10 seconds. If you're one of those 30 people or so who hasn't quite figured out what you want to do, make sure you get it in. Okay, and all right, I am now going to end the poll and I will share the results with you so you can see what's going on. And all right, we've got a pretty good split. A lot of people are leaning towards B and with, some C's and D's in there as well. So that is, let me just make sure I have my copy of the question up on a different screen. All right, so B is the correct answer. And plurality of you did manage to get that, but obviously there's still some confusion within the class. So let's spend a little bit of time and let's go through this. All right, so this is the polls question number 2. Right, and just to remind us, what did it say? So we knew that the sum from I equals 1 to 8, AI was equal to 5. And the sum from I equaled what, 3 to 8 of AI was equal to 2. What is A1 plus A2? Okay. Yeah, exactly. So a lot of people said B. B is the correct answer. And the way that we're going to do this, one thing that's important is to be able to see, like, what does this mean, right? This is just a fancy way of writing a big complicated sum. So if we expand this thing out, what is it going to be? It's going to be A1 plus A2 plus A3. I'm not going to write out every term, but you just keep on going all the way until you get to the number up top, and that's A8, right? So that's equal to 5, right? We know that's 5. And this thing over here, I'll draw this one in yellow. So that's, right, we're going to start when I equals 3. That's what that number at the bottom is. It says this is the number that you're going to start at. So I'm going to write it, and I'm going to write it very suggestively so that it lines up with the thing above it. So we get A8 is equal to 2. And then the question said, what are these two numbers? What's A1 plus A2? What does this equal? And if you look at these two series, right, these two sums, and you say, well, what's the difference between them? Well, the answer is precisely, those first two terms are missing from the yellow sum. So if we want to figure out what A1 and A2 are, we're just going to subtract the first row from the second row, right? So if we subtract the sum from I equals 1 to 8 from the sum from I equals 3 to 8, then the thing that we get left over is precisely the sum from I equals 1 to 2. Or if you want, that's the same thing as A1 plus A2. And so what do we get? We're going to get 5 minus 2 equals 3. That's A1 plus A2, just like that. Okay, does that make sense? Are there any questions about that? Okay, sure. Let me elaborate the last step. So which can you point it out a little bit more? So like, is it this step, like actually the 5 minus 2 part, or like, I assume you know how to do 5 minus 2. So there's something else there that's bugging you.
I mean, like how the second step turned into the last, like the second last step turned into the last step. Like,
Okay.
why would it like why is it that like 8-1 and then 8-3 and we can just minus it, like
Okay, sure.
it
So
sounds like that.
yeah, so the sum, remember what the sum does is the sum, if when I look at something like this, the sum from I equals 1 to 8 of AI, what I'm saying is I'm going to add together the 8 instances when I is equal to 1, 2, 3, 4, 5, 6, 7, 8, right? And we kind of see that that's true up here. So this thing, right, this is the sum from I equals 1 to 8 of AI. And then the sum from I equals 3 to 8 is this thing in yellow. Maybe let me be consistent, write it in yellow. Sum from I equals 3 to 8 AI. So when I subtract them, I'm saying, okay, take all the numbers from 1 to 8 and get rid of the numbers from 3 to 8, right? That's what the subtraction is doing. It's getting rid of the numbers from 3 to 8. And you say, okay, well, what's left over? And the answer is just the numbers 1 and 2, right? If you take the numbers 1 through 8, get rid of the numbers 3 through 8, what's left over? 1 and 2. Does that make sense? Does that answer the question?
I mean, why is A1 and A2 those numbers? That is where I'm stuck, really.
A1 and A2. So what do you mean? Like A1 and A2, we don't know what they are, right? They could be anything. They could be like 10 and 7. What we know is we know that this is 5, and we know that this is 2, right? The problem said that. Look at the top of the screen.
Yeah.
Right. So that's where those numbers 5 and 2 come from. And when we subtract them, we got. Yeah, sorry
for the interruption, but it's asking like what is A1 plus A2, and then like at the end you subtract it instead of like adding them.
No, I mean, like the answer is A1 plus A2. Like A1 plus A2 is 3. I don't know what A1 and A2 are. It's impossible to find what these two numbers are individually, right? Okay, let me try this again. Let me expand this out a little bit more.
I think it will physically help if you actually just put a big line underneath the whole thing and physically subtract them, passing out all these same elements.
Sure. Let's do that. So let's kind of really stretch it out here. So the first thing, this is equal to 5. This is the sum from I equals 1 to 8 of AI. And let's write them all out, okay? So the whole point of this notation is that we don't want to write them all out, but while we're learning, it's okay. We can write them all out. A6 plus A7 plus A8, right? And if I asked you just from this to tell me what A1 plus A2 is, you'd have no idea, right? Because it really depends what everything else is as well. Okay, the second sum is the sum from 3 to 8 of AI. And so that says, right, we're going to start at A3, and we're going to go until we hit the top number, which is A8. A7 plus A8, all right? Okay, now if I subtract these two things, right, what's left over? So I'm going to get 5 minus 2, that's equal to 3. And then if I subtract A1 all the way through A8 and subtract A3 through A8, I get A1 plus A2. Okay?
Yeah.
That's good? That makes sense? People see it? Okay, cool. That's good. So what we eventually want to get to, though, is a point where we don't have to write them all out, right? That we're kind of comfortable with this symbolic manipulation of just the sigma notation. So being able to say from, here, right, that if I subtract the sum from 1 to 8 and the sum from 3 to 8, then the thing left over is from 1 to 2. Okay, so that's kind of our goal. That's where we want to get to. Okay, let's try another one. All right, let's do, yes, I think I wanted to do this one. So let's try that. I'm going to relaunch the poll. Wait, what the hell is going on here? Relaunch the poll, there we go. So do we have to write A1 plus A2 in sigma notation? No, you don't. I wouldn't worry about that. how's the upper limit how's the upper limit 2? I don't know if I answered that question already by virtue of doing it, but if you take the numbers 1 through 8 and you get rid of the numbers 3 through 8, what's left over? The numbers 1 to 2, right? So that's why that upper limit is 2. That's the idea behind that manipulation there. The video, Yingshun, I'll show you where the videos will be posted, but let's wait until maybe the end of lecture for me to do that. Jacob, I'm not certain what question you're asking, but maybe wait till off Sarah's at the end of the lecture. Oh, right. I see. Yeah, maybe, listen, I'll try and give us like 5 or 10 minutes at the end of class. That's a good point, Jacob. I'll give you 5 or 10 minutes at the end of class and then we can talk about that. That's a good point. Thanks. Okay, so you're confused. I mean, talk to me. What exactly is confusing you? You gotta give me something more that I can like sink me and Aziz, something that we can sink our teeth into and help, right?
I'll tell you like this from a perspective, like, because I was a student not so long ago as well. So whenever you see a question, especially in math, that you don't know how to do, try to break down the basics and try to see at least the portion that you do know, how you can break it down, make it a little bit simpler, and then try to find connections between the things you don't know and you do know, and that usually find a good answer.
Yeah, and that's a good problem solving strategy altogether, right? Okay, so Faizan, I would say like you could do a change of variable thing. You could do that. I think in this case, it would be a little bit tricky. I think there's an easier way of doing it. But you can do it that way if you really want. Right. And in that case, you actually have to be a little bit tricky because you don't know how to modify the infinity part with that change of variable, right? And so I would advise kind of in the event that your sum goes to infinity, changing variables is tricky, and I would strongly recommend that you not do it. There is a way of doing it, but it might be a little beyond you. So try and see if you can do it another way. So instead of changing variables, do it very much kind of like we did the previous question, where you maybe add or subtract things that you might need, right, in order to turn one sum into the other. And there's another way too, but we'll get to that. Okay, sure. Yeah, I mean, we can talk about that too, Agam. Like that might be an interesting idea. Like what happens when you start from k equals m instead. Did we resolve that though in Piazza? I kind of feel like we did solve it eventually, but it is a good problem. Yeah, for sure. Okay, I'm going to close it in about 30 seconds too, so everyone get your votes in. Okay, let's end that poll. Let's share those results. Interesting. So again, we've got a lot of D's here. D is absolutely the correct answer. So good job for those of you who got it. For those of you who didn't, okay, we're close, right? There's, some things that we have to work out here, but let's give that a shot. So let's see. So this time we're going to have, oops. Okay. So again, here's the problem. We know, so this is question 3. So we know that the sum from 0 to infinity of r to the k is equal to 1 over 1 minus r. Okay, right? You're told that, you get that for free. You just guess them both. So find the sum from k equals 1 to infinity of r to the power of k. All right. And so there's actually 2 ways that we can do this. And if both can be beneficial depending on the situation that you're in. Sometimes it makes more sense to do one way. Sometimes it makes more sense to do the other, but let's try them both ways. So the first thing that I want to do is I want to adapt the thing that we just did, right? Which is namely, if we add or subtract 2 series, we can kind of see a relationship between them. Let me just maybe write out the sum from k equals 0. Okay, so the sum, if we write out the sum from k equals 0, obviously I can't write out infinitely many terms, but I can start by writing out a few. So I'm going to get 1 plus r squared plus r cubed, and maybe I'll stop at r to the 4 and then just put some dots in, right? So that's what happens with the sum from 0 to infinity. You plug in k equals 0, then you plug in k equals 1, k equals 2, and so on, and then you add them all up. But there are infinitely many terms that we need to add together. And if I take this, the sum from k equals 1 to infinity, r to the k. All right, it's pretty similar, but it starts at r instead of at 1, okay? Oh, why does it start from 1? Okay, sure. So here, you see where it says k is equal to 0? So this is the number you start at. So you're going to plug k equals 0 exactly, Min. You're going to plug k equals 0 into r to the power of k, and that gives you r to the 0, which is 1. Does that make sense? Okay, cool. So we notice in the bottom sum, we start with k equals 1. So we plug that in, and then we continue to increase it until we hit the number up top, but the number up top in this case is infinity, right? Okay, so what is the difference between these two? Like if you look at these 2 series, what's the difference? There's only one thing separating them, right? What is it? Yeah, it's that 1, right? It's the 1. Okay, so what that tells me is that the sum, so if I took 1 plus the sum from k equals 1 to infinity, r to the power of k, that gives me the sum from k equals 0 to infinity, r to the k. Does everyone agree? Right? Because the thing that I'm missing here is that, so if I add it in, I get the thing, the series up top. Do I keep the 1 plus? Well, I mean, right now I need the 1 plus for those things to be equal, right? So that's just me adding in what's missing. And then I can say, okay, well, I know what this thing is, right? This thing right here, we were told that's equal to 1 divided by 1 minus r. And I want to solve for this. Okay, so we know how to do that. I'm going to subtract 1 from both sides. K equals 1 to infinity, r to the power of k is equal to 1 over 1 minus r minus 1. And if you want, you can, give that thing a common denominator. And if you do that, you'll get that thing right there. So that was answer D. Okay, so there's a second way of doing it. I'm going to do that in a second, but does that make sense? Are people okay? Yeah, and Josefa, I don't know if you actually know, but you're only messaging me. So I don't know if you want to only message me or to message everyone in the class, but right now you're only messaging me. Yeah, it's not too bad, right? Okay, but now let me ask you the following. Does anyone see a different way of doing this? So instead of adding the 1, is there another thing that I could have done to make that the top series appear, the 1 plus r squared plus r cubed? what could I have done? Exactly, Emma, thank you. Why don't we factor an R out of the second sum, right? So this is an alternate way. Okay, it's not the same, but alternate. Why don't we write the following? So the sum from k equals 1 to infinity. Let me write this out again. So it's r plus r squared plus r cubed plus r to the 4. And we notice that every single term, why does it become r? Oh, r over 1 minus r? Okay, so like you have to actually do the steps, but try and, multiply both sides, write, -1 as 1 minus r divided by 1 minus r. Now they have a common denominator and put them together, right? Yeah, I should have let you answer that, Aziz. Okay, so we notice that in this sum, going back to this thing right here, in this sum, every single term has an r in it, right? So we know that if every single term has an r in it, we can factor an r out. So why don't I do that? Like that, right? And notice that this thing right here, that's, right, that top series. Maybe let me zoom out a bit. That's that series up at the top there, right? The 1 plus r squared plus r cubed plus r to the 4. And this is sort of the crazy thing that can happen when you're summing all the way to infinity, is by factoring an r out, I actually managed to recover that series. So this is r times the sum from k equals 0 to infinity of r to the power of k. We know what this is, right? The problem told us what that is. So that's going to be r times 1 over 1 minus r. And lo and behold, we get the same answer. And I think that one's actually probably a little bit easier to do it that way. But again, you kind of can do it either way, and you just kind of figure out what works best for you. But those are both perfectly valid ways of approaching this problem. Okay, so are there any questions about this? Yeah, I think this way is easier as well, but it doesn't always work, right? Sometimes it works, sometimes it doesn't work. You just want to make sure and be careful. How do you know that k equals 0 in the alternate form? Oh, okay, sure, yeah. Well, I mean, actually what I did is I simply kind of compared it to, right here, let me just kind of circle this in yellow, okay? And then if I go up here, notice that that is that, right? Those are the same thing, right? They're both 1 plus r squared plus r cubed, right? They're exactly the same series. Okay, cool. All right, let's maybe make it a little bit harder, just a titch, right? Because we want to say, all right, we're comfortable with this now. So let's make it, yeah, sure. So let's make it a little bit trickier. And don't worry too, right? This has been recorded. So, I'm going to post the recording. You guys can check that out later as well. So don't worry about missing stuff. All right, so hopefully you got that. So now let's make it a little bit trickier. Guess I'm going to relaunch that poll. Okay, so here I'm reminding you that the sum from k equals 1 to infinity is r over 1 minus r. We just figured that out, okay? And so given that that is true, what can we say about this thing over here, this sum from k equals 1 to infinity, r to the power of 2k plus 3, right? It's a little bit nastier, so we'll have to do a little bit more work, but I think it's not terrible, okay? It's not too bad. Are B and D the same? Oh, yes. Okay, this is a stupid question in that sense. Let me, here, I'll give you a hint. The answer is not E.
I was gonna say you can just make part E actually D, because on the poll there's only 4 options anyways.
Yeah, sure. Okay. So what do we want to say here?
So ABC stay as is, and then D on the poll is actually E in front of you.
Yeah, sure. That works. Yeah, so D is actually E. D in the poll is E on the page.
Mhm.
Monique, the recording, if you go to the meeting section right now, like I will share my screen and show you all closer towards the end of lecture. But if you go to the meeting section, you will see beside lecture 9104, you'll see lecture materials, and the recordings will be in there. How you got the final answer, the step before the last. Jacob, why don't we'll go back there in a second and we'll take a look at that, because I don't want to change the screen right now. But we'll go back there in a second. Remind me at the end when we've taken up this question, and I'll make sure I answer that question. Okay, and this is really a lesson about trying to reuse the things that we already know. Right. Okay. So we're saying that currently B, there is no difference between B and D. So we're saying ignore D on the screen and instead replace, like cancel out the D and let E be the new D. I wonder if I have the ability to like draw on this screen and maybe do that. No, I don't seem to, or at least not enough right now. But it's okay. Again, it's not worth marks. If you get the wrong answer, who cares? Right. So Talia, I literally just made this like 2 hours ago or 3 hours ago for the profs. They need to upload stuff. I mean, there's obviously nothing in there for me because this is our first real lecture, but the other profs just need a second to upload their stuff, right? So we'll cut them a little bit of slack. Usually stuff goes up within 24 hours. Hell, so, when after this recording is done, it'll probably take my computer about half an hour or so to actually process the video. And then I have to take that video and then I have to upload it to YouTube. And then it takes a while to upload to YouTube, and then YouTube has to process it. So, the whole thing actually takes a non-trivial amount of time. Obviously, I don't actually have to like be there for the whole time, but it takes some time in order for all that stuff to happen. Does this count as tutorial or office hour? It is neither. This is neither a tutorial nor an office hour. Should I book an appointment for office hour? I don't. So for me, office hours are in about 15 minutes, and you don't have to book those, right? Everyone can just come to them. They're drop-in. All right, everyone, I'm going to close it up in about 20 seconds. So get your votes in. And again, if you're confused and you just don't know what to do, just randomly vote. All right, we're getting close here. 3, 2, 1. Beauty. All right, so let's share that now. Okay, so B is absolutely the correct answer. And then depending on whether you understood what we were saying about, D and E and switching a D is also correct because B is the same. But let's take this up and let's see how this is. So this one's obviously a little bit more complicated, but it's the same fundamental principle. So we're still going to have to do a little bit of manipulation in order to make this work out, but it's basically the same sort of thing. Okay, so this is question, what question was that? That was question 4. So question 4. Okay, so we want to find the sum from k equals 1 to infinity of r to the power of 2k plus 3, like that, okay? And we know that the sum, I'm going to write it as an s. It doesn't matter what I call it, right? But we're told that the sum from 1 to infinity of s is s over 1 minus s, okay? And the reason I'm going to use s here is just so that I can call it, you know, substitute s is equal to something later, okay? So I need to figure out a way of reducing this to some sort of expression where I can plug the thing in the right in, right? That's my goal. I need to reduce this so I can plug it into the formula on the right. Now, to my mind, the first thing that I see that I'm really kind of irritated with is this, you know, +3 thing here. I don't like that +3. So what I'm going to do is, first things first, I'm just going to make it go away. And the way that I'm going to do that, you know, you're going to have to remember your exponent rules, but that works out to be like that. Okay, so r to the power of 2k plus 3, if you remember, you can split that up and take that out of the, or you can replace that addition in the exponent by multiplying these two terms. And now this term here does not depend on k, right? Does not depend on k. And since it doesn't depend on k, I can actually take it outside of the sum. Right? This is just factoring. That's literally what I did right there, is I just factored that out. All right. Now I'm almost in a position, right? This looks very close to that sum involving s that's just above it. They look really, really close, but it's not quite, because the sum above has s to the power of k, and the sum that I have here is r to the power of 2k, right? So they're really, really close, but they're not quite perfect. So what I'm going to do, and this step isn't necessary if you understand, if you see what I'm doing, you know, this, you don't have to do this part, but I'm just going to rewrite it very suggestively like that. Okay, so r to the power of 2k is the same thing as r squared to the power of k, right? That's one of our exponential rules. We know that that's true. So I'm going to write it like that. And now if I let s be equal to r squared and use our equation up here, then this is going to end up becoming r cubed times what? Times s times 1 minus s. And now I'm actually going to plug s in, r cubed times r squared divided by 1 minus r squared. And then I'm going to simplify the r's, and I'm going to get r to the power of 5 divided by 1 minus r squared. So that's answer B right there. Okay, so does that make sense? You see how, like, it's a little bit of manipulation. It's not a crazy amount of manipulation, but what we really wanted to do is lean on something that we already knew and then use it in order to be able to help us solve this problem, right? So, and that's something we're going to be kind of doing in general, is like, as we discover more and more formulas in mathematics, we're going to lean on that more. The problems become slightly more complicated, but that's fine, because we're just building on top of that knowledge. And that's why it's absolutely so critical that you, that you understand everything that came before as well. All right, now let me do a quick one, and then Jacob, I'm going to let you ask your question. Is there another way to solve this problem? There might be. To me, this is definitely the best. Like, there might be some roundabout way that we might be able to attack it, but nothing immediately is coming to me. It doesn't mean it doesn't exist, right? But just to me, this is the obvious thing to do, right? That last step again, like right here where I do this, is that the step that's, okay. So what I've said is, let's look at this equation here, and let's compare it to this yellow box. Those are the same thing if s is equal to r squared, right? So the reason why I let s be equal to r squared here, maybe let me just kind of write this on the side here, is because if s is equal to r squared, this becomes r cubed times the sum from k equals 1 to infinity of s to the power of k, and now I can use this formula, right? And so that's what I did. I used that formula at the bottom here, and then just plugged s is equal to r squared back in. Yeah, if you stay back and you give us more questions, absolutely, I'm happy to do that. So yeah, if you want to hang around, I'll give you plenty of questions. Yeah.
We also
so
have some similar questions in tutorials as well.
Yeah, that's true. Absolutely. Tutorials is a great place to go for that because they're going to ask similar stuff. Would we always have to separate the 2 and the k? Yeah, that one's going to be hard to get around. I mean, unless you rederive a formula with the 2 and the k in it. Should it be r to the 5 over 1 minus 2? Probably not 1 minus 2, because that's just -1, right? But no, it's not. If you're saying, is it 1 minus r all squared? No, it's just 1 minus r squared. Yeah, so it should be 1 minus r squared, not 1 minus r all squared, right? Because s here is equal to r squared, right? And 1 minus r squared is different than 1 minus r all squared. Those are different things. Okay. All right. Let me take up a quick. Oh yeah, actually, Jacob, you had a question, right? Which was something about the alternate here. What was it?
Yeah. How did you scroll up a little bit more?
Okay.
It's 1 over 1 minus r subtract 1.
Yeah.
I'm a little bit confused how you got r over 1 minus r.
Okay. So give this thing a common denominator.
Sorry, you glitched out at the beginning of the explanation.
Yeah, sure. So, right, I'm making everything a common denominator. So that's going to be 1 minus r over 1 minus r, right?
Oh, okay. Okay. Yeah, I know what you mean now.
Okay. All right. Yeah, I think we might have time for a last one. Let's see. Do I want to do, isn't that the one I just did? I don't think I want to do that one. All right, here you go.
For future classes, will the poll questions be posted?
They're usually posted at the end of the week, right? Like we
Yeah.
don't want to post them at the beginning because we want class to be the first time, but absolutely they will be posted along with the answers at the end of every week.
Okay.
That's an interesting question. When you want us to say 2 sentences or less, you want us to just explain it in words. You can use math to help you explain, but the idea is, let me pull up the question in detail just so I remember what exactly it was asking.
A fun question.
Yeah, I think they're all fun, personally.
I agree. I have to mark them at the end, so I definitely have to agree.
Yeah. I mean, you can use some math if you want. I think, though, you could explain it entirely in terms of words. So it's kind of up to you. If you want to sprinkle in a little bit of math to justify why that solution is the way it is, I think that's fine. Are you going to get part marks even if we don't get the, I mean, we're all for giving part marks. It depends on how right your answer is, right? Like, we are definitely not, I did have a student one year who got very angry that she didn't get part marks just for making attempts. Like she didn't get effort marks. And we said, yeah, that's not how it works. You have to at least be somewhat right. But yeah, if you're right, but not fully right, you get part marks. Totally. That's a thing. Yeah, then I mean, you should get about half the marks. I mean, part of the process, like, you know, when you marking is not trivial, but it kind of depends on where your mistake happened. If you make a mistake really early in such a way that it makes the problem silly and doesn't, you know, analyze or assess anything that we wanted to test, then you're probably not going to get a lot of the marks. If you make a mistake right at the end, like you did everything correctly and then screwed it up right at the end, you probably get most of the marks. So when you say you get half the process right, it really depends on what that half is, right? And what we're trying to go for, what we're trying to measure. So it's kind of an impossible question to answer. Oh yeah, for sure. I mean, like, yeah, if you just make a little screw up at the end or something, we're not worried about that. Yeah, I mean, generally though, don't round. That's an important thing. Never round. Right, so the topics in the assignments are part of a numeracy thing, which is supposed to be review material. Like this stuff is not using any mathematics that you in theory should not, or it's all the mathematics in theory that you should have learned before coming to class, right? Before even coming to university. So because there's nothing in there that isn't multiplication, exponentials, or logarithms. So that's sort of the idea about that. Oh, you can use pen, pencil. You can do whatever you want. We don't care. I'm going to close the polls in 20 seconds here. So get your votes in. Yeah, I guess back in the day, they used to ask you to write in pen or something. The way it works is you're going to upload your assignment digitally. So even if you write it in pencil, there's going to be no way for you to go back and change that answer, right? So you can write in whatever you want. If you want to write in yellow highlighter, you could. Of course, you got to make sure that your answer is still readable, because if we can't read it.
I was going to say that's the key thing here, because when we look, it's very, like, when you take the picture, you can tell if it's readable and we're okay. If it's not readable, then
exactly.
Again.
Yeah, and Jacob, based off what we just said, if you use your iPad, it's fine, right? Like if we can read it, who cares? Yeah, do it on an iPad. That's totally fine. Yeah, it's probably in fact nicer, right? It's easier.
I strongly agree. Those online ones look significantly nicer than the handwritten ones. So
yeah,
feel free to do so.
Okay, so here we are on this question, and all right, so a lot of people answered A, followed by B. In this case, B is actually the correct answer. And so a lot of people got A and were really, really close, but are off a little bit just by the exponent in the numerator there. So let's try and take this up real quick. So this is question 6, I think, just for reference. All right, so we're trying to figure out what the sum from k equals 2 to 10, 1 plus r to the k is equal to. All right. Now, this one I might go a little bit quick because we are coming towards the end of class, but it's the same sort of idea. The first thing I'm immediately going to do is just do the following. So for me, right, I haven't done anything crazy. I just split this power. So instead of going from k, it goes from, or it has k minus 2 and 2 in it. And the reason why I did that, I'll show you in a second. The reason why I did that, and I'll show you, if you're like, how would I have ever known to do that? Like I said, give me a second and I'll show you. Okay, so I get this. Now, okay, see Aziz? So the benefit here is that because the exponent starts at k minus 2, but I'm going to actually plug k equals 2 into it, I can now define a new variable, which I'm going to call j is equal to k minus 2. So when k is equal to 2, then j is equal to 0. And when k is equal to 8, j is equal to 6, right? 10. Why am I doing 8? It's equal to 8. So this becomes 1 plus r squared times the sum from j equals 0 to 8 of 1 plus r to the j. And then if we plug that into our formula for a finite geometric series, we're going to get 1 minus 1 plus r to the 8 divided by 1 minus 1 plus r. 9. I did exactly the thing that I said we can't do. 1 minus 1 plus r to the 9 all over negative r, right? And that answer is B. Okay, so I suspect there are a couple of questions there because I went through that one a little bit quickly. So ask away. We're in office hours now. If any of you have to run, obviously go run. But you know, ask the questions there because I suspect some people do. I got through high school math on memorization rather than understanding, so I forgot many of what I needed to know for this course. I'm currently trying to relearn anything. Do you have any tips to understand math rather than just memorizing? There always seems to be a fine line between memorizing and understanding through practice. That's true. Okay, Jacob, actually, you know what, Jacob, I don't think it's critical that your question get asked now. Why don't we do it on Thursday instead? Because then that way we know everyone doesn't have a class immediately after, because it's still something I'd like to take up for everyone. And I don't think it's going to make a big difference whether I talk about it today or Thursday. So if it's okay, we'll talk about it on Thursday. Okay. Okay, hold on. There's a couple of things there. Lena, maybe let me come back to your thing later, but remind me if I forget your question, okay? Okay, so let me, so where did the 8 come from? Okay, so the 8, maybe I should actually answer the other question first, which is where did J come from? So what I did is I'm gonna look at the sum here, right? Let's ignore the 1 plus r squared. We don't care about the 1 plus r squared. So we've got this thing, we've got this sum from k equals 2 to 10 of 1 plus r to the k minus 2, okay? Now, if I wanted to, let's actually write these terms out. So I'm gonna take k equals 2, I'm gonna plug it in there, and I'm gonna get 1 plus r to the 0. K is equal to 3, I'm gonna plug it in there, I'm gonna get 1 plus r to the 1, then 1 plus r squared, so on and so forth. And I'm gonna go all the way until k is equal to 8, right? And when I plug k is equal to 10, sorry. And when I plug k is equal to 10 in there, I'm gonna get an 8. Okay, does that make sense? So, I mean, first of all, that's where the 8 came from. So I haven't done any crazy sigma sum manipulation, right? All I'm doing here is writing out actually all of the terms of the sum. And if I said to myself, okay, like I can see that this is actually represented by a sum that starts at 0. Like what if I wanted to rewrite this in a way that didn't start at 2? Then maybe I could define a new variable like this. Right? Yeah, that's okay. Okay, so does that kind of make sense? Do you see how I managed to, first of all, where the 8 came from? And the power of doing this weird let j be k minus 2 thing, the power of doing that is that I didn't have to write out this term, right, to see kind of where things started and ended. But as long as you don't mind writing out the first couple of terms, then you can get to that summation that way. Okay, would it not be plus 2? No, it's not in this case, right? Like what I would say is completely forget this. Okay, don't even worry about that right now. I claim that these things are equal, right? And I think if you look at them, you'll see that that's true, because if I set j is equal to 0, I get the first term. If I set j is equal to 1, I get the second term, all the way through until the 8th term there, right? So that makes sense, hopefully. Gupartap, do you wanna, can you elaborate a little bit more on what you want me to explain? And Rima, where did the minus 2 come from? Where, in the yellow square up top? Okay, yeah. So, or you know what, here, let me maybe solve this in a slightly different way. How did the exponent stop at 8? Okay, let me solve this a different way. Okay, maybe that will help. So the sum from k equals, what was the original sum? 2 to 10 of 1 plus r to the k. Let me write that out. So I'm going to get 1 plus r squared, right? 1 plus r cubed, 1 plus r to the 4, plus 1 plus r to the power of 10. Does everyone agree that if I expand that out, that's what I get?
Yeah.
Okay. So remember earlier where I factored out like the r. So here everything has a 1 plus r squared term in it, right? So I can factor out a 1 plus r squared from everything. Now, if I factor a 1 plus r squared out of this last term, 1 plus r to the power of 10, that gives me 1 plus r to the power of 8, right? And now what I want to do is rewrite this thing in the square brackets as a sum again, because if I write it as a sum, then I can use the formulas that I know. Like that. Does that make sense? Okay, cool. So Brandon, it looks like we got you so there are a couple of other people that make sense to you as well.
Yeah, it helps.
Okay, perfect. That's good. So yeah, that's what's going on there. So hopefully that helps out. Is the formula only works when j or k is equal to 0? Yes, I mean the formula as presented does start at 0. And so if your sum doesn't start at 0, you can't use that formula. But the entire point of doing these manipulations is to say, if your formula doesn't start at 0, how can you manipulate it so that you can eventually get it into a form where you can use the formula, right? That's the idea there. Could you explain the difference between, those are the same, Daniel. So like ignoring the A part, this thing and this thing are the same, right? Because just multiply top and bottom by -1 and like it just flips all the signs, right? So to see that maybe in more detail, so if we've got the left-hand side, rn plus 1 minus 1 divided by r minus 1. So I'm going to multiply by 1 in a weird way, right? I'm going to multiply top and bottom by -1. And if we if we do that, I'm going to get negative rn plus 1 divided by negative r plus 1. And if I just rewrite that in a nice way, I get the same thing, right? So those are actually the same thing. Okay, how did I factor out the 1 plus r squared? So look at this right at the top here, right? We've got 1 plus r squared, 1 plus r cubed, all the way to 1 plus r to the 10. Everything there has a 1 plus r squared term in it, right? And that's how you factor stuff out. Like if I said, 5 squared plus 5 cubed plus ... plus 5 to the power of 10, you could factor a 5 squared out of everything, right? Because everything has a 5 squared in it. So instead of it being 5, it's 1 plus r instead, right? Hopefully that makes sense? Yeah, okay. Rafid, so I understand the second method, but now you're confused on the first one. So I mean, like this first method is just the second method, but where I don't have to write out the entire sum, right? So I'd recommend like maybe practicing with that a bit to see how this one works, but it really is, they're the exact same method. It's just that the first method, compactifies it and uses some different notation, right? Faizan, you have your hand up, I think.
Yeah, I just had a question about, so here where you manipulated it into 1 plus r to the power of k minus 2 multiplied by 1 plus r to the power of 2. I don't see how you got that. Like, how did you come to that?
Okay, sure. So is it just, okay, let me double check because I want to just make sure. So you're okay with this, right? Are you okay with that?
No.
Okay.
Okay, no, wait. Yeah, because it cancels out the -2, right? Or the -2.
Yeah, if you want,
Yeah.
or like y is 5 to the power of 10 equal 5 to the power of 8 times 5 squared, right? That's what I
Because
do.
the power just add, yeah.
Exactly, the powers add. So that's why that step is that way. So does that answer the question, or do you need more?
But I mean, how did you know it was supposed to be 2? It could have been 3 as well, right?
Yeah, absolutely. I could have written k minus 3, and I could have written 3 here. So the reason why I did that is because the sum here started at 2, and I wanted to turn it into a sum which started at 0, right? So what I did is I know that if I plug this 2 into k minus 2, it's going to become 0.
Right.
So that's why I did it that way.
I see. Okay. Okay. That makes a bit of sense. All right.
Yeah, so no, if I'd started at 3 instead, right? If the sum had been, or let's say 4, then I would have probably written it like that instead.
Right.
Yeah.
Make it 0. Okay.
Exactly. How did I get r to the 9 again? Okay, so the formula is the sum from k equals 0 to n of r to the k is equal to 1 minus r to the n plus 1 divided by 1 minus r. And the formula that we had was the sum from k equals 0 to 8 of 1 plus r. I guess I use j. Let me be consistent. Like that. So in this case, n is equal to 8. Right? So if I plug everything in, I'm going to get 1 minus r to the 8 plus 1 divided by 1 minus r. So that's where the 9 came from. Shania, if that makes sense. Or Shania, I don't know. Min, where will the questions for this lecture be? At the end of the week, I'll post all the questions. Okay. Exercise 122. So Emma, I see it. Just give me a second. Let me maybe like make a little note of things. So 21, 22. Okay, and then what should you do if you're not understanding anything? So did you watch the videos before class? Let me just ask that. Or did you just come to class? Because if you just came to class, 100%, I'd be like, oh, where can you watch it? Okay, here, listen, let me show you where the videos will be too. Okay, so let me share another screen. Desktop 2, no, I don't want that. 133, there we go. Okay, so exactly, yeah, exactly. So readings is where the videos are. Okay, no, that's fine. And it's your first lecture. You'll have an opportunity to come back and watch them. So I'd say try and watch these videos for next week. Today's lecture was just basically based off of this video. And then Thursday's lecture will be based off of these 3. So just, tonight or tomorrow when you get an opportunity, watch these videos and then maybe try the exercises. And I think that's why you're like, I have no idea what's going on, is because you just didn't know that you're supposed to watch the videos, right? So that's okay, but now you know. And then come to class and you'll be okay. Is there writing? There shouldn't be a writing assignment due next week, but somebody else has said this as well. Oh yeah, it does seem to say 2020 thing. Let me just quickly check. So on my thing, I have the writing assignment due. Oh yeah, so I'm going to post the writing assignment tomorrow, right? So that's that. Thank you. Could you go over the assignment briefly? Yeah, I've got a to-do list of things, and the assignment is definitely one of them. Okay, let me just very quickly answer because a bunch of people are asking about exercises and lectures. So Alessandro, you're asking where you would find exercises. So the exercises can be found in the textbook, and the textbook can be found in your materials. So here are the notes, here is the book, and at the end of every section, there are exercises there. And then there are solutions as well if you click this link, okay? In terms of the recordings, so obviously the recording's not up right now, but if you go to meetings, you can see that each lecture has a lecture material beside it. If you click the one beside our lecture section, right? Currently there's nothing there because obviously, we haven't posted it yet, but it'll be there, okay? So that's where the recordings are. Is there an assignment we have to hand in on September 17th? Yes, there is. So start that very soon. That's what everyone's asking about in terms of the assignment. Will week 2 be posted? Can we watch videos ahead? Sure, yeah. I mean, I usually post them, I think, on Wednesday. But like, if you really want, I could try and find time to do them today, but usually I post them on Wednesday. So you'll have an opportunity to watch them ahead of time. Oh, also, if you just go to the YouTube channel with the, here, right? So here's the YouTube channel, and then you should be able to pull up the playlists. You can just find all the videos for the course here. So if you really want to watch ahead of time, and they're in the correct order, right? Oh man, I don't want to hear myself talk. But anyway, they're in the correct order. So you can just go through this playlist and you can just watch the entire next 3 weeks of videos if you really wanted to, right? Where do you find what? So go to the readings and pull up the actual YouTube page. Don't watch them embedded in the Quirkus. Pull up the YouTube page, and from YouTube you can find the channel with all the playlists and all that. Okay, so if you want to get ahead, for example, that's how you do it. No problem. Okay, so assignment, problem 22 and problem 21. So those are the things that I think people wanted me to talk about most. Let me just reshare my other screen. Sure, we'll just share the whole screen, I guess. All right. Okay, so let me pull up. So Hala, they're in the lecture material on the meetings page. Okay, let me, and also everyone, on Friday, I will make another announcement for the following week, and I will include links there as well, showing everyone where those pages are, right? But if you go to the meeting section, look at the lecture 9104, you'll see lecture materials, it'll be in there. Okay, so let me just open the book so that I can get the questions in front of me. Otherwise, I'm going to be trying to guess. So let me do. Yeah, it's obviously chapter 122, right? Not 222. Yeah, the exercises are in the book. Absolutely. Okay, yeah, sure, Ron. So go to the meetings section in Quirkus, and then in lecture, you'll see our lecture, right? It's where you would have gotten the Zoom information for this meeting right now. And now you'll see a little link there that says lecture material. And if you click that, that's where the recordings will be. Okay, and you can try it now and see if you can find it. There won't be anything there, but the link is there. Okay, so let me start off. Okay, this is the order I'm going to do things in. I'm going to do 122, 121, 122, and then the assignment, because a bunch of people have been asking these questions. Okay, so 121, 122, and the assignment. So this is 122, or sorry, 121. I don't know why I keep saying that. My brain, clearly, I'm a little fogged up, right? Okay, so we're told that A is the sum from 4 to 8 of 10 to the power of L, and then B is the sum from J equals 1 to 5 of 7 to the J, right? Write A plus B with a single summation. Okay, this is a nice question. Okay. So the critical thing here, notice that both of these sums have exactly the same number of terms, right? In fact, if we write it out, right, we've got 10 to the 4 plus 10 to the 5 plus 10 to the 6 plus 10 to the 7 plus 10 to the 8. And then we've got B is 7 to the 1, 7 squared, 7 cubed, 7 to the 4, and 7 to the 5. And we want to write these as a single sum. And the reason why that is kind of difficult is because, well, A starts at 4 and B starts at 1. So we could do a bunch of like manipulation if we wanted to. We could actually manipulate the sigma notations. Alternatively, one of the things that you could just do is shift down. Yeah, exactly. So you could shift down, or you could shift B up, right? You could shift B up. Yeah, that's the book. So you can shift A down, you can shift B up, or you could just make a new one up, right? So why don't I say, so we want to do A plus B. I'm going to do a new index. I'm going to call it K. And what number do you guys want to start at? Literally just choose a number, whatever number you want. Where do you want the index to start?
5.
1.
Okay, a lot of people said 1, so let's choose 1. I'm sorry, I know you got 5 in first, but we're a democracy here. So we're gonna start with 1. And okay, let's write 7 to the something, I don't know what this is, plus 10 to the something, I don't know what this is. Okay, so what should the power of 7 be if I want to capture these two terms? right? So I want to capture 7 to the power of 1. What should the power of 7 be if k is equal to 1?
1.
Okay, no, but I want it in terms of k. So you're right, it's going to be 1, but I want it to be in terms of k right now. So k is going to be equal to 1. So this should be 7 to the power of
0.
A.
yeah, k, right?
Oh.
Right, because when k is equal to 1, actually, I wonder if maybe there's a different way I could explain this to make this a little bit more clear. Okay, let me try it like this. Okay, so I want these to be the same thing. So here I'm going to have k is equal to 1. So I want to write this as 7 to the 1 plus 7 to the plus 10 to the 3 plus 1. Does that make sense? Right, because this is where k is equal to 1. Here, what I'm going to do is I'm going to write this as 7 to the power of 2 plus 10 to the power of 3 plus 2, right? That's going to be these two terms here. And then I'm going to do you see the pattern, right? So this is going to be 7 to the 3, right? Plus 10 to the 3 plus 3. Okay, so when I do the actual sum, I'm going to get that. Does that make sense? Does everyone kind of like see?
Yeah, because like k equals 1.
Exactly, right? So it's kind of like, what's the pattern? 7 to the k plus 10 to the 3 plus k, right? That's the pattern. And so once I figured out the pattern, that's going to be the summation. So now the question is, where does the sum stop? Okay, what is the biggest value of k if I use this pattern, right? It's going to stop here. What's the final value of k? 5, exactly. Yeah, I got, sorry, that one was a direct message, so you guys didn't see it, but yeah, exactly. The final sum is k is 5, and we can double check it, because if we plug k equals 5 into this, we should get 10 to the power of 8, and yeah, that is actually what we get, right? Oh no, don't worry about private messaging. I just figured maybe you didn't want people to see your answer, but that's okay. Sure, the transforming method, I can show you that, yeah. Okay, so we've got, let me just rewrite them out again in terms of the transforming method. So what did we have? We had L equals 4 to, what was it? 8. 10 to the L, this was A. And we have B is equal to the sum from J equals 1 to 5 of 7 to the power of J. Okay. So when the answers vary, yes, absolutely. Yeah, if you choose different values, there's totally infinitely many different numbers. That's why I actually said, tell me all what index you want me to start at, and I'll actually do the problem. If you choose a different starting index or finishing index, you would get totally different answers, right? Like the number is the same, the answer is the same, but the way that you would present the answer is different. So definitely there are different, infinitely many different solutions that you could have to this. Okay, so still though, we have to decide to re-index this. And usually you want to shift either A down so that it starts at, the sum starts at 1, or you want to shift B up so that the sum starts at 4. Okay, so I guess we're going to shift it down, right? Because that seems to be the thing. So the idea here is I want to change this. So the sum starts at, let's say 1 instead of 4. Okay, so here's kind of a little cheat of how I would do this. Because if I just write out the answer, I think you'll all be confused. So I know that the first term is going to be when L is equal to 4. And if I plug that in, I'm going to get 10 to the power of 4, right? And I want to shift that down. What's our new variable going to be? Let's call it k. It's going to be when k is equal to 1, I want this to still be 10 to the power of 4. Right? So I need to figure out, okay, in terms of k, how can I write 4 in terms of k? Well, that's probably going to be k plus 3, right? Maybe it's 4k, but you have to kind of look at the pattern and see, well, I'm just increasing by 1 every time. So that's going to be k plus 3. Does that make sense? Does everyone kind of see how I did that, how I just kind of finagled it? Yeah. So this tells, okay, good. So this tells me exactly what the change is going to be. So I'm going to let k plus 3 be equal to L. Or if you want, you could say k is equal to L minus 3, right? Those are the same thing. So now I'm going to rewrite my sum. So I've got A is equal to the sum from L is equal to 4 to 8 of 10 to the L. And now when I rewrite it, everywhere I see an L, I need to change it. Right? 10 to the something. I don't know what to put here. I don't know what to put here. Now, you don't want to write, the bottom index should always be L equals or K equals, right? You don't want to write K plus 3 equals 4 here. That's bad form. Okay, don't write that as the lower bound of your summation. It should just be K equals something. But like you can see what it's going to be if you were to solve this equation for K is equal to 1. Right? You agree? Or alternatively, what you could do is you could say, look, up here, K is equal to L minus 3. So when L is equal to 4, K is equal to 1, right? So that tells me that I'm going to put a K is equal to 1. And exactly, the top is 5, right? So the top up here, you'd say, well, what goes there? Well, when L is equal to 8, K is equal to 5. So then I would put a 5, then I would put a 5 up here. And the power is K plus 3? Exactly. The power is K plus 3 because originally it was L, but now we know that L is equal to K plus 3. So I'm going to put that in there like so. Oh, sorry, K plus 3, not L. Okay, so now I've rewritten A so that it starts at 1 and goes to 5. So now I've got A plus B is the sum from K equals 1 to 5 of 10 to the K plus 3 plus the sum from J equals 1 to 5 of 7 to the, what was it, just J? And you say, okay, well, they're different letters, but remember the letter doesn't matter, right? The letter it's a dummy variable. It's just kind of keeping track of what's going on. So now you can combine them and let's maybe use I. It doesn't matter, right? It's a dummy variable and you can combine them and you get the same, in fact, the same answer that we had before because we started our index at the same place. Okay, so that's how you would handle that problem. I would recommend as an exercise that you try shifting up or that you try shifting both to something in between. Like maybe you want to restart and try to do your index at 2. You could totally do that. And that would be a good exercise to see if how good you are at re-indexing things, right? And you can just do this as much as you want until you are really comfortable with it. And then, you know, nothing can stand in your way, right? You're just a master re-indexer. Yeah, you could change them both to 0. So maybe let me just kind of show you what you would do for that rather than kind of go through it all. So if A is equal to the sum from L is equal to 4 to 0, you would do A is equal to the sum from K equals 0 to 4 of 10 to the K plus 4, right? And you can see it starts and stops at the right place. So you switch the letters to J. Yeah, I mean, the letters don't care. Right? Like you don't, the letter is just a placeholder. So if you want to change the letters, it doesn't make a difference. Yeah. So group, sorry, I just brutalized your name. I'm going to do 21, 22, and then the assignment. Okay. So if you can hold on a little bit, I will get to the assignment. What did I do in the last step? I mean, I basically just did this. Changed all the letters to I. And then smush them together, right? Because the letters don't matter, right? The letters don't make a difference at all. And what was it? J is equal to 1 to 5, 7 to the I. So if you were to re-index this so that it started at 0, you would get 7 to the J plus 1, right? So now if you want to smush them together, you can. Exactly. There isn't a single final answer. There's a bunch of ones, right? So if we combine these, we would get A plus B is the sum from K equals 0 to 4. Oh, sorry, this should be 4 up here. Of 10 to the K plus 4 plus 7 to the K plus I, or K plus 1. That's also an answer, right? There's actually infinitely many answers depending on how you choose to start your index. Okay. Now I know some of you want me to get to the assignment, so let me jump off of this one In a test, how can I explain A equals? You could just say, like, you can see up here, I said, you know, this. So you could say like set L to be equal to K minus 3. And that's how you're telling the marker that you're re-indexing, right? Or you can do it like I did above, and you can actually just write it all out and say, I'm going to choose to index this as such and such and such. Okay, let me take 22 so I can get to the assignment, because I don't want to run out of time here. So 122, and again, this is all still being recorded, right? So you guys can get to it. Yeah, write in whatever you want. It doesn't matter. Okay, so I don't know if you guys noticed, I've actually updated this one because some students pointed out that there actually is a typo in it. So the sum from 1 to 20 of AR, or I'm using I, so let me change that. AR is equal to 52. Sum from R equals 1 to 11. AR is equal to 23. Sum from R equals 11 to 20. AR is equal to 37. Okay, and there are a bunch of ways that you could solve this. I think the easiest way is to add these up. Okay, just straight up add them. And if you add them, what do you get? So the number wise, we clearly get what, 60, right? If you just add them. Okay, but this is not equal to this thing, right? It's not equal. For this, it was originally Emma, you're right, but I have changed it because a couple of students pointed it out, right? That you couldn't actually figure out what A11 is. The best you could get was A10 plus A11. Okay, so Curdy, I'm going to show you why in a second. Yeah, exactly. So yeah, you were probably right, and this is why it was bugging you, because you couldn't figure it out because I made a mistake there. So that's on me. That's not on you. So let me show you, Curdy, why we would add these together. Now, when I add these together, what number? Oh, sorry. 11. What number is counted twice? Right? Which AR shows up multiple times? $11, right? So we add up, this is the same thing as adding up all the numbers once, but I added up 11 twice. So I'm just gonna add it in again. Do you all agree that does this make sense? Because A11 shows up both in the sum from 1 to 20, and then I've also just said, oh, look, there's an extra one hanging around. Okay, but we know what this is, right? That is 52. So A11, so we've got 60 is equal to 52 plus A11, and so that tells us A11 is 8. Okay, now some other students did some clever things as well, where they would do like, they would subtract some of these from each other, and we're able to isolate for a sub 11. And that's phenomenal. And if you want to do it that way, you absolutely can. I think it's a little bit more work than doing it this way. But this way is maybe a little bit more clever to see why that works. But it is absolutely possible to solve it just by like subtracting things, very much like we did in the very first problem today in lecture, right? So if you want to do it that way, you absolutely can. And it would be good practice. And I recommend that you try it that way. Okay, any last minute questions about that? Otherwise, I'll hit up the assignment because I know that a bunch of people have really been asking about it. No, it's okay, hopefully. And if you're writing, of course, just keep writing and I'll come to your question. Now, for the assignment, I assume nobody has an issue with questions 1 or 2 because they're kind of fluffy, soft questions, right? So those probably aren't the issues. Now, for those of you who asked for the assignment, which question in particular? Like, is there a question that is bothering you? Because I'm not gonna solve the assignments for you. 4-3, okay. Okay, so everyone, it seems like 4 is the one that's bugging you all, right? Yeah, sure, unmute.
I was just wondering, like, the assignment, like, as a whole. So, like, it says question 1, like, for the first one, like, all answers to this problem can be found in like the course syllabus. And then like, how would you want us to like respond to like those little questions? Just like write them out on paper or something? Like, I'm very confused on like what we have to basically.
Yeah, totally. So where it says like you know, what are the meeting ID and passcode used to access tutorials in Zoom? Just write it down, right? Like you can go on the syllabus, it's like 978-555-6222. Just write that down as question 1.1, right? So is the question about like how you would actually submit that, or just the framework, like how you're supposed to present your solution?
Honestly, both of them. Like, how am I supposed to present it? And then like, would you want me to like write it on paper and then take a picture and then submit it there? Like, how would that work?
Okay, so have you visited CrowdMark at all? Like, have you played with that?
That's how I did it. Like I write it on paper and then like I took a picture and then
No, actually,
and
I haven't.
Okay, yeah. So, you know, the thing is, I can't show it to you on my end because my end is the instructor version. But log into CrowdMark, and there is here. Let me share my screen here.
Yeah, could you please show how like I can actually get into CrowdMark?
Okay, sure. If you want to, so first of all, you can just like Google CrowdMark if you want, but alternatively here under regular assignments, there is a CrowdMark link. And I think if you click this, it will take you to the CrowdMark website, maybe not. I don't remember exactly where I put the like link to get to CrowdMark, but like legitimately, if you want to get to CrowdMark, all you have to do is put CrowdMark in. I use DuckDuckGo. I assume you use Google. You'll get here, and then sign in, and then you sign in with your normal institutional ID, right? And you should see you like 133 appear here, and if it doesn't, you should email me so I can make sure that you're in here. Right, and then once you've written it on a piece of paper and taken a picture, or if you want, you can put it on an iPad and download it as a PDF or whatever. There's even a question here called uploading practice, so you can upload stuff and see how it works without worrying about whether you're actually submitting the assignment problem, right? So I'd recommend giving that a try, seeing how that works, and then if you're having troubles with that, then emailing me, and we can go through it and I can help you out. But I think it's pretty intuitive. Like, it's not like crazy hard to do. Like, it gives you an interface. It says upload your solution to question 1 here, and you drag and drop, or go to a file explorer and add it. And then it uploads for you and you're done, and you hit submit, and then we can mark it on our end. And for those of you asking about like pen or pencil and everything, this is why we don't care, because we have a digital picture of your assignment. You couldn't change your solutions if you wanted to, right? So does that make sense? Does that help you? Like, I'd recommend playing around with this and seeing if it makes sense. And you can do that as much as you want in upload practice, right? Yeah, Faison, what's up?
Yeah, so I have 2 questions.
Mhm.
So the first one is if you go back to the first question we did today,
Mhm.
how would that change if, let's say, the first summation stays the same, but the second one, let's say I starts at 4. So how would that change? Because that wouldn't be A plus B, that would be A plus B plus C, right?
It depends on what question. Okay, so hold on, because there's a couple of things here. So before I jump to another question, though, I know that some students had other assignment questions that they wanted to ask. So let me just make sure that I cover that, because I know that they've been waiting very patiently, and then we'll cover yours.
Sure.
Okay. So does this answer the questions about like how to use CrowdMark and the assignment, though? Is everyone okay with that, or is there something left about how do I actually submit my work?
This is a question about the assignment.
Okay, wait. So is this a different question than what I'm doing right now? Like how to upload?
Yeah.
Okay, so just hold on a second. And then somebody else was speaking as well. So whoever you were.
Oh no, mine wasn't about submitting. Mine was just like more of like a different question for the assignment.
Okay, sure. So yeah, let's do the assignment questions then. So not submitting. So for those of you who have questions, I think most people said numeracy 4 was bugging them. Yeah, is that fair?
Before we start numeracy 4, what would I do? Like for me, like personally, like I'm looking at this and I've like never done this before. At least I think I've never done this. I probably have, but like my mind's just like going very blank right now.
Okay.
Is this stuff we should have learned in like calculus or something? Like,
Okay, so for which question? Like numeracy 3, 4?
numeracy, yeah, 3 and 4.
Okay, like they're not necessarily things that you should have done, but they're not things that where the math should be new to you, right? Like numeracy 3 is multiplication for the most part, right? Like there's nothing there that's crazier than multiplication. And in numeracy 4, it's also mostly multiplication, but with a little bit of logarithms. So it's like, you know, even if it's not 100% familiar to you, the math isn't new. Or that's the hope, at least. Okay, so let's, yep.
So the first assignment isn't like from the first 2 topics that we covered, is it?
No, right. Yeah, it's supposed to be like a review of high schoolish things that we were
Yeah.
going to use in the coming weeks.
Okay.
Yeah, Abraham, sure, unmute.
Hi, Professor. I just had a question for numeracy 4, question 3.
Okay.
Am I supposed to use the function that I got for 4.1 or the one in 4.2?
It shouldn't matter.
Because if I use the one in 4.1, I
Mhm.
get 2 different answers. If I use the one in 4.2, I get 1 answer.
Okay, let me just read it quick. So suppose you're told P not greater than 0 R is less than 0. Right. Okay, yeah, use 4.2. Use 4.2 for 4.3.
Okay, and also, am I supposed to write the questions down on the paper or just
No,
like...
no. We don't need you to repeat the questions.
Okay, thank you.
No problem. Faizan, you're saying it's hard to understand what the numeracy questions are asking. So try and give me more detail. Like what particularly is a confusing instruction to you? Like where are you stuck, right? So give me something that you're stuck on so I can elaborate on it more. And they're both very compound interest related. Yeah.
Yeah, so for example, the first one, numeracy 3, like as a function of TR and like, I don't know what it means by as a function of like.
Okay. Yeah, absolutely.
You get to rearrange it.
Yeah, so it means that your answer should look like little r is equal to something. And the things on the right-hand side should be only capital T, capital R, and capital N. And maybe like a one.
Rearrange it for that. Okay.
Yeah, exactly. Just solve it.
All right. Okay.
And so that would apply for numeracy 3.2 as well.
Yeah, it's just that like I understand like how to do them. It's just hard to like I don't think I've ever come across this type of like vocabulary, I guess.
Okay,
like,
sure.
Like they just write out the question, which is why it's a bit difficult for me.
Yeah, so yeah, so this is actually standard vocabulary. Like there isn't anything weird about what we're using. So what we're saying here is like, for example, you are now expressing R as a function of these other 3 variables, right? And the function is if you write y is equal to x squared, you've written y as a function of x, right? And maybe it's just because we're not familiar with playing around with functions of multiple variables. But if I wrote y was x squared plus z, then I've written y as a function of x and z, right? So yeah, so all we're saying is here, write r as a function of these other 2 variables. So solve it so that it's r equals something.
Right. Okay. Thank you.
No problem. Okay, so is there more? Ibrahim, is your hand is still up, but I don't know if it's because I've answered, like you just forgot to put it down, or if you have another question. Or does anyone have other questions? Otherwise, I'll go back because somebody was asking about. Okay, so ask it. And if you want, you can unmute. Like that's totally fine.
So my question was, I'm not sure if I'm writing, because you told us to write in sentences and explain like what we're doing.
Mhm.
So I'm not sure if I'm doing it properly. So how can I check if I actually am or not?
Yeah, that's a great question. Office hours, you can show it to me. You can post it on Piazza. You can, like, as a lesson, if you look at how I've written solutions in the book, that is even probably too much, because in the book, I'm trying to really explain it, right? I'm not writing to somebody else who knows as much math as me, which is how you should be writing. But often we're not looking for like crazy long stories. what we're often looking for is let's define X to be this thing and do this computation. And then you do some computation. We notice that this is true and then do some computation. Do you know what I mean? Like we just don't want long pages of mathematics. We want you to just give some explanation about what it is you're trying to do at any given point.
Okay, so how can I show you it during office hours?
I mean, like, yeah, if you don't mind people seeing, though, if it's an assignment question, you probably shouldn't.
Yeah.
But what you could do, for example, is post it to Piazza and make the post private so that only instructors can see. Right.
Okay, because I asked the same question on Piazza, and they said so basically they won't be able to help me and tell me if I'm doing it correctly or not.
Oh no, we can totally do it. Just make sure you don't post it publicly.
Okay.
But yeah, I'll look for that Piazza post and see who said that, because like we're more than happy to help with the writing as well.
Okay.
Yeah.
Thank you.
Sorry, can I have quick questions?
Yeah, of course.
Yes, so first with the numeracy 4 and question 2, I wonder if I should stop my calculation at the Euler number, or should I use the Euler number that you use in your note to calculate the final number?
So for 4-2?
Yes.
Okay. So you're not certain if you should use the Euler number to do what?
Like, because I got the calculation down to the Euler number. So like my final calculation include the Euler number in that. So should I use the Euler number that you gave me in the note?
Well, there is only one Euler number, right? So like you should use that number, yeah, 2.71828, whatever.
Because it's an endless estimation, right? It's endless. It's supposed to be endless, right?
Yeah. So I mean, what I would say is, first of all, when you solve it, leave your answer exact. Like don't round it or plug it into a calculator. If you want to plug it into a calculator, most calculators do have that ability to handle that.
Right. And another one that you might have already answered is numeracy 4-3. So the final questions.
Yeah.
So should I use the information in 3A to 3A or 2 to answer 3B, because I need to refer, right?
Right. Let me see.
I think he's asking the same question that I did.
Okay, I see.
I think I did.
Yeah. Well, specifically asking about 3B and whether or not you use the information. Yes. Yeah. Like you shouldn't need to use A per se, like 3A. You shouldn't need to use it. But it is still using the Euler number expression 4.2, right? Because 4.2 is the only one with a little r. So when it tells you that little r is less than 0, we have to be referring to 4.2. But you shouldn't need 3A to answer 3B.
Okay, so I cannot use like the one that you already gave in numeracy 4 at the title.
What do you mean?
Like if I want to use the formula like Pn.
You have to justify why it's true always, right? Like if n is bigger than m, you have to, like, if you claim that Pn is bigger than Pm, you have to tell me that this is always true and not that it's true for a particular n and m. Does that make sense?
Because I want to use some equation that you already used to justify my answer, right?
What equation?
The one at the like we compute Pn by multiplying Pn minus 1 by r. Okay. So
I mean, you can use that for sure. You can use that.
Okay, I can use that, right?
Yeah.
Okay.
Yeah.
Perfect. Thank you very much, Professor.
No problem. No problem.
Appreciate that.
Can I solve an example that's similar to numeracy 3 and I don't know how to begin 4-1? Okay, let me see. So Kurti, actually, I don't mind helping you for this one. This might be something that's better done on Piazza though, so that I don't give too much away. Kurti, so if you throw this question on Piazza, I will help you out there. And or is there something similar I can do that doesn't give it away? Let me think. Okay, you know what? I think we can just kind of do it. So what is P1? What is P1? Give me an expression for P1. And Kurti, I want Kurti to do it. I know that some of the rest of you know it, but what is P1? Okay. So what is P1, right? So it says you're given a number P naught. After 1 minute, you multiply this number by R. Right, okay, sure, yeah. But so Kurti, are you okay with that? That it's this? Does that make sense? Okay. So what is P2? Right, P1R, does that make sense? Everyone's okay with that? Okay, now let's not stop here. I know what P1 is, right? So if I plug P1 into this, what do I get? So I get P naught R times R. And if I simplify that, what do I get? Exactly, P naught R squared. Okay, that's okay so far? Everyone's all right? Okay, what's P3? Sure, I mean, you're jumping ahead a bit, but they have P2R, right? And then I know what P2 is, so I can plug that in. And so on. Oops, P3R. Do we see a pattern? Right, and that's what the question is asking you. What is the pattern? What is Pn, right? If I replace Pn is equal to P naught what? All right, P naught R to the something. Yeah, okay, does that make sense? Okay, and then in 2, what you're gonna do is you're gonna repeat the same process, but instead of multiplying by R, you multiply by e to the R. Okay. Yeah, we did it as a class, right? I think that's okay. We all did it together. So, so for 2, I'm not going to do 2, but you do exactly the same thing. So you would multiply by e to the R instead of capital R, right? And then question 3 is its own thing. So does that help for numeracy 4? Is everyone okay with that? I would not necessarily keep the n outside. I'd actually put the n inside. I think it's a little bit easier if the n is inside. Just because when you eventually have to do the part where you actually solve for little r, it's easier if it's inside. Yeah. Okay. Now for numeracy 3, somebody asked me to do a question similar to numeracy 3, but numeracy 3 has a bunch of different parts. So what in particular, is there anything, it's supposed to be r raised to the nth power? I mean, kind of, it depends. So I am asking you to use some knowledge of the exponential rules here in order to manipulate this a little bit, but it is easier if you put the n inside the exponent. Yeah, it's fine. I mean, if you don't put it inside, it's not the end of the world. Like your answer is still correct. It just might affect how you solve the problem, but it's not a big deal. Right, and it doesn't, if you did put it in, but you put it in later, it doesn't matter. As long as you put it in eventually. And again, you don't even have to put it in, it's okay.